Hello, my name is Sanjay Manney. I am a Director of Product Planning and Product Management at Xilinx in the Data Center Group, and I'm here with my colleague, Pradeep.
Hey.
Go ahead.
Thank you, Sanjay. Hey, hello everyone. I'm Pradeep Nallimelli from Xilinx. I work as a Systems and Solutions Architect in Data Center BU of Xilinx and primarily focusing on networking and security. Good to see you everybody here, and let's start.
Thank you, Pradeep. So today we'll be talking to you about Xilinx's Alveo U25N SmartNIC product and focusing primarily on networking offloads for enterprise data centers. The talk today will be in two sections. In the first section, we are going to be talking about just general trends in the market, about how NICs have evolved, where SmartNICs are going, and what the market needs are, and then introduce to you the Xilinx U25N SmartNIC. It's a 2 by 25 gigabits per second SmartNIC for the enterprise. So we'll focus on that for the first section. In the second section, we'll dig into some details about the architecture for the U25N and some of the more popular use cases that we see in the enterprise that the U25N is tailored to solve. Evolution of NICs. We've seen NICs evolve over the last 2 decades. People were all familiar with traditional or so-called standard NICs. Their function was fairly simple: to interconnect computers at relatively low speeds, receiving Ethernet packets, passing them on to the host CPU for processing the networking stack in software. And this approach was just fine when port speeds were low, such as 1 gigabits per second, and possibly even up to 10 gigabits per second. But several things have changed in the data center over the last decade or so. Many new technologies have been introduced. Data centers have grown and scaled quite dramatically. The number of servers deployed has grown quite dramatically. And the networking burden on the CPU has gone up as well in order to keep up with these trends. So what NIC suppliers have done is to overcome this additional workload on the CPU. They've created what were called offload NICs, which essentially process some of the network processing functions in hardware in the NIC itself. And the technologies chosen were fixed function ASIC-based implementations, which were fantastic in the job that they were proposed to do, which is to offload the CPU. But by their very nature, they were non-programmable, and the offloads that they were able to cater to were pretty much determined at the time of creation. And then you had to live with it until the next generation of the ASIC showed up. So the timelines for feature introduction was fairly slow. And as we all know, networks evolve much more rapidly than hardware cycles can accommodate. So that brings us today to the SmartNIC era of NICs, where programmability is very important. So they use a combination of ASICs with fairly high performance ARM processing subsystems, as well as FPGAs and other programmable engines. Again, the intent here is that the number of offloads that can be offered by these SmartNICs is pretty broad, and the feature velocity in which new offloads can be provided to the marketplace goes up quite dramatically. And so that's where we are today with SmartNICs. They're called by different names in the industry. You hear popular names these days called DPUs or IPUs. They all fall into this category of SmartNICs. The U25N that we're going to talk about today does fall into the same category as well. So we look at Xilinx, the SmartNIC market, in 3 broad market segments. The first is the Fintech market that we are traditionally quite widely deployed in. The nature of this market is it's truly about lowest latency, trying to get the packets from the network as quickly as possible into the CPU for trading decisions. And Xilinx has come up with several technologies to cut the latency of this path. We acquired a company in the last 2 years called SolarFlare that was one of the leaders in this space. One of the technologies they offer is Onload, which is a kernel bypass network acceleration stack. The general trends in the fintech market space are that there's more of a need for inline computing, where networking and computing are done at the same spot in the network as the packets come in. And this reduces the latency for making decisions in applications such as real-time risk analytics. And the network is a very crucial part of the value proposition for these infrastructures. So we're very widely deployed, very well known in this space in the fintech market. The next market that we cater to is the hyperscalers, which is the extremely large data center deployments. These hyperscalers are pushing the limits of technology, especially in terms of port speeds, 100 gigs today and moving to further higher speeds relatively soon. These customers and markets care about customizability. Each one of these hyperscale data centers is unique in their own way. The workloads that they cater to and the telemetry and the amount of data they have about how to optimize their networks is so proprietary and unique to each individual hyperscaler that they have large teams, developer teams that they maintain and are able to program their own SmartNICs and offer the most optimal solutions for themselves. So having the resources to do their own development and deployment, as well as customizability without trading off performance, that's what they care about. Deployments are typically virtualized as well as bare metal deployments. So it's a fairly complex, high performance environment. And that brings us to the third market segment, which is the tier 2 cloud service providers, telcos, and enterprises. These infrastructures, data centers, tend to be a step behind in terms of their port speed requirements. Today, they're mostly at 25 gigabits per second in terms of network speeds, but they tend to have similar needs in terms of the services they offer and the offloads they need from SmartNICs. But one difference is that they're not prepared to do a lot of development on their own. They're expecting vendors such as us, Xilinx, to provide turnkey solutions for security, virtualization, and other such offloads, which we'll talk about. So on top of that, they do want to keep their options open to add a few developers and further enhance and program these SmartNICs just a little bit to be able to optimize their infrastructures. Server manageability is supremely important for them. So they want these to be able to deploy in standard OEM servers, fully qualified, ready to use, and having a broad breadth of support for all the various OS distributions that these enterprises use. So ease of use, turnkey solutions, very important for these customer base. That brings us to Xilinx SmartNIC Portfolio. So we have a portfolio of products that caters to each one of these markets. The X2 adapter product family is one of the leaders in the fintech market. Very likely that every time you make a trade, somehow or the other, your data is touching one of our X2 family of products. So we've been in this business for quite some time now. The SN1000 was a product that we recently announced earlier in the year. This is a dual port 100 gig SmartNIC. That is the entire networking stack, SmartNIC networking stack, is deployed entirely in programmable FPGAs, as well as a high-performance ARM processing engine. So it's an extremely composable, programmable SmartNIC. Again, this is meant for the hyperscaler market. And finally, we have the U25N, which is a dual 25 gig half-height, half-length adapter card, primarily tailored for tier 2 cloud service providers and enterprises. So there are several trends that are
Can I ask that question real quick?
Yes.
Just out of curiosity, I know usually when you see the higher end FPGAs on video cards, there's always some enormous heat sink and fan because of the power requirements and the heat. How do these compare to other NICs as far as power consumption?
No, that's a great question. You're absolutely correct. I mean, with programmability comes the cost of power and performance. But one of the things you'll see in the way we architected, for example, the U25N, is it fits into the standard 75-watt half-height, half-length PCIe card budget. In fact, it runs fairly lower than 75 watts. We use a combination of technologies internally. Where it makes sense, we offload the processing in fixed function hardware. Where it makes sense, we offload the processing in programmable logic, and some of it also in ARM processing engine. So we have a combination of these heterogeneous architectures, and we partition the functionality amongst these engines for the best trade-off of performance, cost, power, and the benefits of and flexibility of programming as well. And you'll see that in the next few slides. We'll talk some more about it, but that's a great question. Thank you for that. So some of the trends we see, we talked about overburdened CPUs and how it's necessary to offload, and these CPUs are monetizing engines. So the more you can get networking stacks off of the CPUs, the servers are more widely available for revenue generating purposes for the customer. We also believe, we've seen that in order to get the proper trade-off of efficiency of scale, cost advantages, and performance, you need to provide hardware acceleration. So functions such as open virtual switch acceleration, IPSec acceleration, firewall acceleration, quality of service, and we'll talk about some of these use cases in more detail. Without having a proper hardware acceleration that is still programmable, it's difficult to achieve the proper balance of power, performance, and cost. And we talked about the need for complete solutions. Enterprises are looking for turnkey offerings that they're able to deploy quickly and use very little of their own engineering resources. And then finally, as we said, the port speeds are still today at 25 gigabits per second. And so we went about defining a product primarily for this space with the U25N.
Sanjay, could I ask you a question?
Sure.
So I'm guessing that a lot of our viewers are not really familiar with the Xilinx name. And I'm wondering if you could touch a little bit on whether you're selling these products under your name, or if they're being white labeled by some of the bigger names that everybody knows, or a combination of the two.
Yeah, no, thank you for that. So in fact, the Alveo product family that I mentioned, and you see in this picture here of the U25 branded as the Alveo card, this is our family of PCIe adapter cards. They are part of a portfolio of acceleration products. Today we're talking about the network acceleration products. Xilinx Datacenter Group has released over the last couple of years several products in this family that range from video acceleration to compute acceleration and Fintech acceleration products and so on. So the entire family of PCIe adapter card acceleration products that Xilinx sells as turnkey offerings, both a hardware product as well as the platform and the solutions that go with it, are all branded under the Alveo product family.
Okay, thank you.
So talking about the U25N in particular, it is built on a proven X2 high performance NIC ASIC, which has been widely deployed in the Fintech space. We take advantage of all the learnings and the investments and the maturity that went into both the hardware as well as the drivers that have been deployed in various infrastructures. So we've kept and preserved that when building the U25 product. It offers turnkey solutions for powerful accelerations for OVS, IPSec, firewall, and quality of service. And then it maintains the programmability, and the programmability can be done as hardware programming through RTL or through some higher level programming language such as P4, and we'll talk about that. Xilinx offers a technology called DFX, or Dynamic Function Exchange, where you can change the personality of the FPGA by loading in a new image or a bit file, and this can be done dynamically at runtime. And that gives the flexibility of changing the personality of the hardware within the infrastructure without redeploying it.
Can I ask on that note, how does the network see this device? Does a network switch see the card as the network interface, or is the network device that doesn't see the machine behind it or the machine that's plugged into? Or how does that translate?
Yes, so the network sees this as a standard NIC through a Ethernet interface on the network. On the host side sees it as a standard Linux driver that comes with the card. So it's very transparent. All of the accelerations that we offer are quite transparent to both the software developer as well as the applications that are running on the host. And from the network, it's a very standard, Ethernet 25 gigabit network that can plug into standard 25 gig Ethernet switches.
Okay, thanks.
And to build on that, do you see the drivers being included upstream in the Linux kernel at some point, or are those likely to remain an add-on product or add-on driver?
So I'll defer that to Pradeep, if you want to add something there.
Yes, that's a good question. So the network drivers for U25N are already upstreamed. So because the U25 is an heterogeneous product, it has an X2 ASIC in it, right? And X2 has been there in the industry for the last 10, 15 years. Okay. So we are going to leverage the same driver that already upstreamed into different variants of distributions out there. So when you plug in U25N, we could able to detect the card as U25N network device driver. The net dev will get hooked into it by default. And then when we want to offload the SmartNIC acceleration stuff, we're going to allow the customers to go and download the accelerated and optimized driver from our launch that will enable them to run these workloads.
Okay, thank you.
Thank you, Pradeep. The U25N also has substantial amount of onboard DDR memory, so we could support large number of rules. So it's a fairly high performance SmartNIC in a pretty nice and tight small package in a half-at-half length card. So let's get into one level deeper into this architecture. So the FPGA itself that goes on this card, or before I get there, so I want to just describe to you the picture on the left there. It shows three important engines there. There's the X2 Ethernet controller, which is that ASIC that we talked about that has been deployed in all of the X2 family of products in the Fintech market. We preserve all of the offloads that are offered, and since it's in the form of an ASIC, it gives you the best trade-off in terms of performance, cost, and power. And these are functions that are standardized for quite some time now, so they don't tend to change quite a bit. And the driver interface is a standard X2 driver that's been upstreamed, as Pradeep just described. Now, behind it is the FPGA. We use a powerful zinc-based FPGA, which is a heterogeneous device in itself. It supports both the FPGA programming logic, but also has 4 A53 ARM cores running at 1.5 gigahertz, and we make good use of that. So those engines are actually processing the packets from the network and offering the networking offloads within the hardware right there. And in this combination of functionality that's split between the FPGA and the ASIC, we're able to achieve pretty low power. Typically, we operate at around 40 watts, and we're able to put it in a small package in a half-height, half-length, fits into a single slot. The networking interfaces are standard SFP28. Interfaces support both copper and optical cables. and the host interface is a PCIe Gen 3x8 interface. Memories, we have up to 6 gigabytes of memory supported with ECC protection for data center deployments. And then there's card management, a fairly robust stack of card management that allows these products to function right out of the box in standard servers such as Dell, HP, IBM, and so on.
Sanjay, I'm sorry, and this is really cool. I'm just having a hard time thinking about who you're selling to client-wise, because I think as I work for an enterprise and I think about it, we're either we're going cloud or we're buying from a named server box, and we're not thinking about the insides other than what they're selling. Who's your actual clients?
So that's a great question. So our channel or distribution partners are traditionally the server OEMs, but these cards are also available through distributors. So we work with a variety of distributors, such as Avnet, so they can be procured that way as well. The solution itself, as Pradeep described, is offered directly from Xilinx. The software and the bit streams that give the card its personality and its acceleration is offered directly by Xilinx. So it's a turnkey offering. So we're not relying on an intermediary or a third party to complete the solution for us. We go through the qualifications in the server ourselves. They're certified and tested and ready for use for any of these standard server deployments.
So you have competitors, and I won't name names, but I know Mr. Foskett has probably had them on before, and you're going up against them. But it sounds like you're doing your own stuff as well. That's right. I mean, I think the market requirements are that there's value in the hardware, but really, if the hardware is not completed with a complete solution, then the benefits take much longer to be realized by the end markets. And we hear that loud and clear. Majority of our investments internally go into preparing the solutions, validating them, making it easily deployable in standard environments, standard servers. So over the last few years, the data center group at Xilinx has done a tremendous job in stepping up and offering these board level products as a complete solution. Okay, thank you for that question. And then finally, this is a datasheet-like view of the U25N. It supports all of the basic NIC features. You can see them as standard Ethernet features, standard stateless offloads, things like checksum, large packet handling, TCP/IP, UDP handling, overlay like VXLAN and so on, as well as providing features for server virtualization, such as SRIOV, VLAN tagging, and support for standard distributions, such as Ubuntu and others. And then card manageability, standard protocols that are used in card management within various server environments, such as NCSI, PLDM, MCTP, and so on. So all of these features are pretty much table stakes, but these are offered directly from Xilinx in the products themselves. And what we'll focus on in the next section is the advanced features that go beyond these basic features and how we offer offload performance for enterprise data centers. Next week, we have the Xilinx Adapt conference. It's a technology conference of all of our products that we've been working on with contributions from partners and customers. It spreads out over a week, so feel free to sign up for it, learn more about not just the networking products or the U25N, but there's a bunch of other data center technologies and products that you'll hear about, which you can take advantage of.